Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. Hello and welcome. I'm Peter Ballant from Technicon, and today we look at the certMILS project. This EU-funded effort is researching ways of keeping complex systems safe and secure. Think about trains or power grids. Unfortunately, these systems consist of so many independent components that certifying their integrity as a whole would become an unwieldy task. Using the existing MILS, or Multiple Independent Levels of Security platform, certMILS seeks to find ways of shortening, simplifying, and implementing new certification methodologies with the ultimate goal of efficient security in cyber-physical systems across Europe. Today we speak with Thorsten Schulz from the University of Rostock and Sandro Rauscher from Thales. Both gentlemen are project partners in certMILS. They join us remotely from their home offices today. Welcome, and I think the place to start is to understand this concept of multiple independent levels of security. Tell us, Thorsten, what is that all about?
So MILS, it's even though it's not supposed to be that abbreviation anymore, it's like the lettering together of multiple independent levels of security. So that's where it started out of. So maybe coming from different perspectives, nowadays, like networks are always like in larger company networks, you divide them up in zones and different places where you have different abilities or maybe different services. So separating up a computer system into different kind of zones, into compartments or maybe partitions or domains is really important to separate the security of such a system, because once you have these kind of compartments, one can define the interfaces between the compartments much better, and then it's much better to also define security measures afterwards.
Yeah, do you have anything to add to that, Sandro?
As Thorsten already said, we're dividing different components on a single computer system into different parts. So you can say the multiple independent layers in this case are several operating systems running on top of each other, and they have to be secured.
So is this about security, or is this more about reliability, or both?
That's the good question. So it's actually both. While it has been used, this kind of architecture concept. So it's not really a standard. MILS is not a standard. It's an architecture concept. So this can be, at first, it can be also really used to. It's also called separation of criticality. So this, as you said, like for reliability. So, for example, in one of the compartments of the systems, you would like to have maybe the braking system, something, and you don't want to have the braking system connected to the internet. For whatever reason, you don't want to have that. So you really rather look into having that separate, and maybe have a different kind of a compartment that takes care of connecting to the internet. And then you have a very confined, thin communication channel between these two components. And just making the point that in comparison to like years ago, when we would have two different devices, like only two different physical systems taking these functions apart, nowadays for reducing the costs of the system, and even for physical products, just reducing the weight, we put that on the same machine, kind of computer device. And we need software methodologies or software architectures where we have still similar idea as what we would have beforehand when we had separate devices.
And in this project, certMILS, are you actually making anything, or is it more conceptual, or is it working on a architectural concept?
So that would be my part. I'm doing the whole architecture for the Thales demonstrator, which we already presented. And I can describe it as there is an operating system running on our hardware board, which gets inserted into the train. And then on top of this operating system, which is running with, we call that bare metal, there is another operating system starting on the bare metal operating system, and then another one. And we interconnect them so that everything is confined in a certain way, so that certain functions cannot be accessed from the outside.
And somehow we always seem to be going back to this train example. Is that considered a primary use case for you in certMILS?
So we have 3 different demonstrators. One is the train use case, which is from Thales. Then the next one would be the subway demonstrator, which is actually really different from the rail demonstrator. And we also have a smart grid demonstrator, which is used for electrical grids.
So these are big infrastructural items. I mean, this is for major systems.
Yes, that is correctly. So, but these are actually components within these larger systems of systems. But you could use the same architecture. For example, I know back in the years I was thinking with a friend of mine. So, what if the person that does the train, the closing the doors, the one that stands outside, so basically the steward of the train, would have a smartphone that can kind of stop closing the doors, or maybe induce open the doors and anything of that. Then that smartphone, you wouldn't want to have that just pressing the button, just being able by some random Google Store app. So, but you want to have that separate. So you could even think of a smartphone having like a separation architecture, as we talked about that. But in the other side, we really concentrate on the components first, which are important for our critical infrastructures. As Sandro said, for the smart grid, where we want to have the substations that should be reliable. And like when you have a power outage, like a blackout, the whole system has to be quickly back up again and has to work smoothly, even if it is based on kind of in networking or internet technology. And for the train system as well, so we're not talking about just trains. So actually, trains are not really part within these certMILS projects. So it's more the signaling part that we're looking into. And for the signaling part, also, you have a lot of small signals scale, like thousands around, for example, in Germany, another thousands in Austria and all over Europe. And these systems have been, like years ago, they've been driven by cables, like iron cables being passing around. But that has changed. So you want to have commercial off the shelf bus-based systems. And these have to adhere to some kind of common methodology to make them reliable and secure.
Okay, good. And I wanted to ask you, Torsten, and then I'll get to you, Sandro, about your contributions in the project. Torsten, you're bringing experience and real-world activities from an academic perspective. What benefits does that have for the project in general?
So from my perspective, it's important to have that kind of separate view sometimes. It doesn't mean that I have to see things differently. It just, like on university, I'm not directly driven by kind of a product, or that I have to have some kind of sort of output. So I might be a little bit more open, and there's about 2 contributions that I'm trying to achieve here in this project. So the one thing that we kind of signed to do was a little of security testing to add that. Just to be honest, we add that from our perspective that we know a lot about embedded systems, because at our institute we have been doing embedded systems for like beginning of the 90s. Before that we did chip design, but so we have kind of that perspective. But there's also a second part to it. So once we develop the pilots, as Sandro says, so for the smart grid railway, these are pilots that we're trying to certify. And once we have pilots that are being certified, we have to be really careful about the confidentiality, about the software related to this. And it's really hard to bring examples or just any notion of how this works out to the kind of audience of listening things. So I have a little bit more of the choice maybe to try use different software, but on the same architecture, and then publish this through kind of open source projects. So I did like a few contributions to a railway network protocol in the last year, and I'm also probably will continue to do that. And I can also publish some source code how I would do like a MILS system related to a railway signaling system, just something that is not really usable in the railway because it's not certifiable, but at least somebody that people can look at so to understand what does the MILS architecture actually mean.
Okay. And Sandro, you're bringing experience from a large manufacturing and research company, I would say, right? How does that benefit the project?
I think Thales brings a lot of experience into this project. As for myself, I'm only working there for about 2 years now. We are having like 70,000 instances of our software running right now across the globe. And we are supporting our software and hardware for at least 35 years as of now.
You representing Thales, what can you bring to the project?
Thales brings a lot of experience from the communication sector and from the rail signaling sector. And me, from myself, I come from, let's say, a hacker point of view, and I view the system a little bit different than other people would do, like software architects. So I'm looking more to exploit all of this stuff so I can actually prevent something like that happening.
Aha, very interesting. So you approach everything from kind of the way a hacker would. So, okay, you look at the holes that are existing perhaps and try to figure out how you would exploit them and then maybe patch those holes up. So let's sort of take this and look at it in a real life example. Like I heard somewhere about a train's getting hacked. Does this sound like an appropriate case to talk about when we talk about certMILS? Because certMILS obviously has some relationship to the railway and it's also about safety. So can you give us a scenario of what might happen if a train was hacked and why would somebody want to hack a train?
Yeah, of course. So you have to think about different threat actors. So who wants to attack a critical infrastructure system? And yeah, why would you do it? So the threat agents we actually defined or are common to these scenarios are even nation states. The motivation could be that the shutdown of public or military transportation would be beneficial for someone for strategical reasons. Yeah, let's say cyber criminals could also hack it, like botnet operators, because they could actually like to pay the operators some kind of ransom money. So they take the whole system in ransom and say, yeah, you got to pay. You may have heard about that all ransomware, which encrypts your data and then tells you, yeah, give me 1 Bitcoin or you never get your data back. Something like that.
Yeah, we've talked about this in earlier podcasts. Yeah.
There's also the possibility that there are other corporations that want to attack the availability of the system in order to lower the reputation of the other company. Or
Oh boy.
one of the funniest things are like insiders. So an insider actually knows a lot about the company, of course, and they may have different levels of motivation, let's say like revenge. There's a pretty funny case in Vienna with the trams. There was a guy who got fired, but he got a hold of the key for the tram, and then he stole it and just ran around with it. That's what you want to not to happen.
So if this train hacking takes place, what does this look like for the average person? I mean, is just trains stop, they're not moving, or can it even be more dangerous than this?
I think maybe I just from my perspective, I would also think like we all have seen what shutdown looks like in the past weeks. I know maybe if you listen to the podcast a little bit later, but you will probably still remember what shutdown means. So this is a large like economical impact. So shutdown to public infrastructure, not just to a train but also to smart grid, has a really incredible impact. Just also with the oil piling up. So just trying to shut down the train system. So at first it will just probably just stop. There's a lot of safety margins or safety issues, so it will just all stop. But even stop would be absolutely critical for the whole system. So I think this will be the most general because, as Sandro says, like hacking a train, like if you have a key, then you probably have a process problem within your company. Like if you have a physical key, because this is one of the last resort things to actually access a device. But getting like remote access, so if you have one key, you can probably get into one train or maybe another train or whatever, something, but that doesn't scale. But if you have remote access to all trains, for example, or to all signals, then you can have kind of hack thousands. So that's completely a different issue. And so when hacking a system, like a system of systems, I think that the scale that you can reach is the big problem. And when we're talking about designing components that should be secure, then we're talking about components that, as Sandro says, have like 70,000 instances around the globe. And we're not talking about two trains or maybe one tram going a little bit wild, maybe just heading into the next switch point. But it's like thousands of trains or thousands of systems being shut down. And that is a really critical issue that we're looking into when we're talking about security hacking. It's not the single occurrence, but the scale of problems that can arise.
Yeah, and so which I wanted to add, something I wanted to add is from a hacker's perspective, the weakest link is in this chain is always the human being, because there are there's stuff like social engineering. So let's say, Peter, I want some passwords from your server. What am I going to do? I'm going to call your company, or I'm going to find out some numbers of your colleagues. I'm going to call there and I'm begging that the new boss that you have that's so mean to everyone that's going to fire me, so you have to give me your password. And you're probably going to do that. Yeah, and you can say exactly the same for the trains. There are some maintenance workers, maybe they're oblivious, maybe they are convinced to do something malicious. You don't know that.
Yes, and I think also one of the approaches is so. I mean, there's always ways to find access into a system. So that's as Sandro said. So you do social engineering, social hacking, but we're talking about a lot of remote devices that are just dug up in some pile of dirt or somewhere along the track, or maybe somewhere totally internal into a train or any of these. So there's definitely going to be remote access, and probably a lot of people also from the technical community know that there are always security vulnerabilities. And when we switch all the devices that we're using for, like, obviously for cost reason, to commercial off the shelf products, like in the past, train related hardware has been, or also for all critical infrastructure, has been quite special hardware. But once we move, for example, to x86 hardware, or for example, any of the general purpose ARM processors, they're getting quite famous nowadays, they all have common vulnerabilities. And these are actually really common to natural PC hardware, which is much more around the world. But so if you have kind of a ransomware that was meant to be on some kind of personal laptop, and then it also works for the train system, that is really a problem. So that's why we have to harden the train system and be really quickly to be able to update. So maybe coming back to this issue that I stated at the beginning, that getting trains, the whole, I think it's called homologation approach. So getting trains and signals and all these safety critical systems certified takes years. So if we have a CVE, so that's a common vulnerability that is found, so any kind of like a security hole, then we would have to go like through the 2 or 3 years again to certify the system, just to get the security update into the system. And that is completely, that doesn't make any sense. So that would leave the system for 2 years completely vulnerable. So that's why we have the MILS architecture, where we can, on the one hand, can have a like really short security update to, for example, to the communication module. But the communication module, on the other hand, is not safety relevant because, as I said at the beginning, like if we have in another compartment, we have the braking software, we're not going to touch the braking software. It's still the same. And we can prove, so that's the important thing, by really rigorous tests that these two systems, so the communication component on the one side and the braking software on the other side, don't interfere with each other. And then we can say, like, if they don't interfere and we want to prove the safety of the braking system, but we have to update the communication component. So that's kind of maybe, it won't be internet, but it's kind of like for example, like a VPN tunnel or something. We need to update that due to this common vulnerability. Then we can do that, and we can do it quickly within a couple of days. And if we don't have something like the MILS architecture, where we have certifiable components that are separate from each other, that don't interfere with each other. So if we don't have that, we can't have these kind of systems. So that's the importance of having the certifiable systems that can be separated and can be partially updated without interfering with the safety of the core functionality. Does that make sense?
It makes sense, and I have to wonder then, is a project like certMILS, is it sensitive to the fact that technology is changing rapidly?
Yes. Yes, definitely is. So, I mean, we all want, for this, there's the other thing that I also like as an example. So we all want this remote maintenance. So we don't want a system to be down. Like we all expect the trains to come there like every day on the second. So we don't want them to be on maintenance like all the time. So we want to have, when they need maintenance, we want them to go in, do the maintenance, and come back out again. So, but if a train has some special kind of issues, or whatever device has issues, found out, for example, the braking system found out, like I have extra wear, and then we can use the remote component, like the remote communication component, what we call then predictive maintenance. So the braking system can kind of acknowledge to the central workshop, to the maintenance workshop, that there's a special care needs to be taken. And then only then, if that is necessary, the train has to go into maintenance. So we can probably also increase the maintenance cycles, like make them larger, and increase availability for the devices that we need in our critical infrastructure. So I think this is also one of the use cases, I guess, for modern, like you call them, like, these kind of systems, critical systems.
Right. And Sandro, from your perspective, what does success look like in this project? So when this project is done, what aspect, once it's complete, will make you feel good?
Success would look like for me if the whole thing is running. It is actually right now. There are certain demonstrators that work. The main achievement would be, as Thorsten said, that you can actually exchange everything in a matter of hours, and everything works remotely. And if that is set up and everything works flawless, and all, let's say, most of the security vulnerabilities are mitigated or eliminated, then I can speak from success.
Okay. And Thorsten, how do you answer that question? When you walk away from the project, what does it look like if it was successful for you?
Because like me being at the university, and I'm basically limited to my external projects, so I will also leave the university quite soon. If I see these kind of technologies, if I see them again, like when I enter that kind of, I will be going into this kind of software market, and I'm totally interested in that, and I really like it. And if I see the success of this architecture and this technology, and if I can say like, right, this train is going for maintenance and it's not being hacked, it just works. So technology, I think the best success is always technology that works.
Well, thank you both for taking the time to share your knowledge with us today. Best wishes for the remainder of the project, and we'll talk again real soon.
Thank you.
Thank you, Peter.
For more information about certMILS, visit their website at certMILS.eu. This podcast has been brought to you by Technikon. The certMILS project has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 731456.